alcohols. And what are we going to do in alcohols? First of all, the general formula for the alcohol. It is CnH2n plus 1 and then OH. Okay. Now, how to start working on the alcohols? First of all, if I take methane, CH4 is the formula for that. Methane is going to lose one hydrogen. What is left with you? CH3. This is methyl now, right? So if I connect CH3 with an OH group, this is now methanol. The name will end up with OL all the time. Are you with me?
Yes.
Okay. So
Yes,
the name is going to end up with OL all the time. So it's methanol. Okay. So from methane, it's methanol. From ethane, it's ethanol, propanol, butanol, pentanol, hexanol, heptanol, octanol, nonanol, and decanol. Right?
Yes, sir. Yes.
So we have methanol, then we have ethanol, then we have propanol, butanol, pentanol, hexanol, then heptanol, octanol, nonanol, and then decanol. Okay, it starts with 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5 carbons, 6 carbons, 7 carbons, 8 carbons, 9 carbons, and 10 carbons, right? What was the general formula which I told you? I told you it is CnH2n plus 1 and then OH. Let us see the formula, that are we really getting this or not. So methanol formula, we have written it is CH3OH, right? CH3OH, it's methanol. Now, N starts for carbon atoms, right? So if carbon is 1, put the formula and put the values plus 1 and then OH. So CH, this is 3 and then OH. So yes, the general formula is correct. Okay? Are we clear with this?
Yes, sir. Yes, sir.
Now, ethanol is the most important one. Methanol is also important, but in your course, ethanol is important because most of the questions they are coming out of ethanol. So we will work on the ethanol now, and along with that, we need to be doing the naming also. Okay. Now, working on ethanol, it is C2H5OH. First of all, preparation in your course, and then comparison of the preparation methods. Okay, this is for Edexcel. Okay, so preparations are classified into 2 categories. Number 1, laboratory preparation, and number 2, the industrial preparation. Both are equally important in your course. Okay, so we will work on this one. This is high important. Before that, we'll work on the nomenclature, so how to name alcohols. Okay, we'll work on that, and we will see whether there's an isomerism there in alcohols or not. So let's try first of all how to name them, and are we able to find any isomerism there in it or not? Are you getting my point? Naming alcohols. This is called IUPAC. Some people call it IUPAC, some people call it IUPAC. International Union of Pure and Applied Chemistry. They have given the nomenclature for them, and how to name them we'll see it right now. Let us start with 3 carbons, and because 2 carbons we have already talked about it, it's ethane. 3 carbons if we have. So the first thing, the rules are the same. We are going to count the longest chain of carbons, and we are going to give the least value to the group connected here. Okay, so OH is connected to the first carbon, the rest all are hydrogen. If I'm not showing, it's an expert way. If you're not showing it, it means it sends. Every examiner is picking this for hydrogen, these lines with carbons. Every carbon should be satisfied with 4 lines. So you can see this carbon is satisfied with 4 lines, this one with 4 lines, this one with 4 lines. It means that carbon can maximum go for 4 covalent bonds, so you should not exceed that limit. Okay, sometimes we start drawing in double bond and we just make a different way out of it. Like for example, in a double bond, we are moving in a speed. So 1, 2, 3, 4, 1, 2, 3, 4, we do this, and this carbon is now neglected, and you can see 5 bonds are there, so this means it's wrong, right? So we need to avoid that. Keep this in your mind. A single line will give you no marks if you just exceed the limitations. Now, what's the name of this one? First of all, this is propane. The longest chain is for propane. Okay, so we have the longest chain here for propane. So it's basically propanol, but which propanol? The alcohol is on position 1, so we need to give it the position also. So we will call it propane without E, 1 and ol. Are we clear with this? It's propane 1 ol. If I shift this hydroxy group to the second carbon, then you will see that it's giving me a different name. So it is 2ol. You getting my point? If I shift the hydroxy group to this carbon, will it be 3ol? Will it be 3ol?
No, sir.
No, sir.
No, it's wrong. It will not be 3ol, because I'm going to start the counting from which side? I'll start the counting from 1, 2 and 3. From the side which is giving least value to the branch or the substitution or the functional group. So what will be the correct name for this one? It will be propane 1ol once again. You need to be very careful about it. The starting carbon and the ending carbon, we start counting with the carbon which is giving least value to the branch. So now the least value is from this side, and before it was from this side, right? So propane 1ol and propane 2ol, what are these two to each other? Isomers. These two are isomers to each other. Are you getting my point? Is it clear?
Yes.
Okay, if I draw ethanol and if I try to name in this way, can I name it as 1ol? This is ethanol now. 2 carbons are there. The OH group is connected here. The rest are all hydrogen. right? It's ethanol. Can I name it ethane 1-ol? It is actually ethane 1-ol. But why we are calling it just ethanol? Because there is no other probability in it. For example, if I shift the OH group to the other side and I just draw it here, will it be giving me some different structure? So if it was supposed to be giving me some different structure, then I would have called it, for example, if ethane 2-ol could have been possible, then I would have been talking about ethane 1-ol and 2-ol, right? If there is no other possibility, so this is also ethane 1-ol, the scientists are saying call it ethanol then, instead of calling it ethane 1-ol. In fact, it is ethane 1-ol, but there is no other probability in it. There is no 2-ol probability. If there is a 2-ol probability, like for example, there are two students in one class, both are having the same names. So when you're calling them, for example, Farhan, and both are Farhan, then they get confused. So you have to do something. In the classes, we call it Farhan 1 and Farhan 2. Okay? Then Farhan 2, yes, then he'll respond to you. If there's a probability. If there's only one single person in the class, Farhan. So Farhan khalas, why Farhan 1? So this is how we are doing with the ethanol or with the alcohol. You have any question? Do you have any question?
No, sir.
No, sir.
Okay. Now I'm moving towards your book. Let me open your book and then we are going to start from the from your book actually. Let me follow that page. The chem book page, where is that now? Okay. Let me open that book. So can someone tell me where is the topic on this book? Quickly.
Sir, page number 288.
288?
Number 26.
288?
288, chapter number 26.
288. I was already on 390. So 288. I think I've reached. Okay. I told you about that. Alcohol we are studying right now, and we are moving to the objectives. The alcohol contains the OH group, already discussed. Understand how to draw the structure and displayed formula of methanol, ethanol, propanol, propane 1-ol only, and butanol, butanol 1-ol, and name each compound. It can be 2-ol, 3-ol also, okay? Can be 2-ol also, or butanol. They're saying only this one you should know, but they can ask about it. Know that ethanol can be oxidized by burning in the air. We will work on this in the next class. Reaction with oxygen in the air to form ethanoic acid, and heating with potassium dichromate in dilute sulfuric acid to form ethanoic acid. We'll work on these also. And then know that ethanol can be manufactured by reacting ethene with steam, that is the industrial process. Conditions are very important, okay? A temperature of about 300 degrees Celsius. You have to memorize these conditions, okay? Because they are carrying solid marks, so they will ask about what are the conditions for industrial process of making ethanol. So you will say 300 degrees Celsius of temperature, 60 to 70 atm of pressure, and phosphoric acid will be the catalyst for it. These three conditions. So solid 3 marks are there. And then we'll work on the fermentation of glucose in the absence of the air and an optimum temperature about 30 degrees Celsius, right? 30 to 40 degrees Celsius. And we are using a catalyst that is the enzyme yeast, and especially zymase is used there in that condition. Understand the reason for fermentation in the absence of air at an optimum temperature. We will talk about these also, okay? Now, as I discussed with you, these things. See this now? This is ethanol. I've already drawn the formula for you. We've worked on it. And this is ethanoic acid. So later on we'll work on the ethanoic also. Okay, if you look into your book, there are some yellow lines given there, some strips are there, then extension work is also mentioned here, and you've been asked that, okay, go through these things and find out what is happening here. Okay, now here in this topic, what are we going, how do we find that whether we are dealing with alcohol or not? Okay, and laboratory method of understanding whether the liquid that you're working on, is it alcohol or is it not an alcohol? So we need to have a reagent for it. The reagent is potassium dichromate, which is K2Cr2O7. We are using this reagent. Okay, potassium dichromate or potassium dichromate chromate 6, right? This is a strong oxidizing agent. It doesn't work without sulfuric acid. So what are we going to do? We are going to prepare this solution with sulfuric acid, and then we are going to add alcohol to this, which is C2H5OH. Any of the alcohol you add it here. If you see the color changes there, it means it's an alcohol. If there is no color change from orange to green, it's not an alcohol. Okay.
Sir, your screen is stuck. Okay, now it can.
Are you clear with this? If we prepare this solution and we add alcohol to it, and the alcohol is if the color is change of the solution from orange to green, it means that the solution that we have added actually is real alcohol. It doesn't mean it's ethanol or methanol or any other one. Keep in mind, when it comes to alcohol, most of the students, they ask that is it the drinkable one? Every alcohol is not drinkable one. Keep this in your mind. The wine that is available, it has a different composition. Okay, so alcohol is a group of compounds. It's a homologous series actually. It's a very big group of compounds, just like alkanes and alkenes. Are you getting my point? And there can be medical uses of it. There can be some other chemicals which can be extracted out of it. So now, safety note: when you're using, you're working in the laboratory, definitely you have to be very careful about it. Wear eye protection and add the reactants very slowly to prevent too violent reaction. Do not point the mouth of the test tube towards you, as the contents may spit out, and if they're heated up, definitely they can burn you and they can